Yesterday, somebody asks me, Sir, please explain the principle of reverse shoulder arthroplasty. So, first we revise a high school rule that if this is the fulcrum or axle, this is the rim which is trying to move it. Supposing this is with spokes here like this is the wheel. Greater the distance of the force from the fulcrum, lesser will be the force required to move it. So if this is a wrench and you have a longer wrench, you will be able to move or overcome the friction of this point more easily. Friction is resistance to move. In a shoulder which is converted from cartilage to cartilage to metal on metal or metal on plastic, the friction or resistance to move is vastly increased. So to move that, to facilitate movement by the lesser force of the deltoid, you need to increase this distance. So here is the formula. If we want to move a hard fixed axle, greater the distance between it and the force, lesser will be the need of the force to move it. So this principle F into D is equal to torque or force that can be exerted to move the axle or overcome its resistance to move, which is also called as friction. Now see this in case of a normal shoulder. Normally, if this is the head, the lesser tuberosity, the center of the head is the axle. And the deltoid is the force. And the distance between the deltoid and the center of the head is normally it's quite low. So if we make the socket, the glenoid, the ball, if we make this socket, the glenoid, the ball, and we make the head the socket, we can move this axle downwards and medially and increase the distance between the deltoid and the axis. And the effect would be that the greater friction between the two components, the glenoid and the head of the humerus component, the greater friction, because cartilage is more slippery than 30 times more slippery than skates on ice. And no human implant can reach that level of less friction. So we want to increase the distance so that the force of the deltoid can easily move the joint. So this is the formula. F into D is the torque needed to overcome the friction. And if we increase the D, lesser F will be able to achieve the movement. So in a reverse shoulder arthroplasty, the D is increased by moving the axis of movement medial and lower than that of normal head, by making the head the socket and glenoid the ball. So here the head is the socket and here the glenoid has become here the head is the socket and the head is the ball and the glenoid is the socket, and here the glenoid has become the ball and the head has become the socket. And this distance has increased. So in this circumstance, more force will be needed to overcome friction because the distance is less. Here the distance is increased, so less force will be needed to move the joint. So this is the principle of reverse shoulder arthroplasty, because in the reverse shoulder arthroplasty, the friction or resistance to move between the joint surfaces increases. To compensate that, you increase the distance so that less force will be able to overcome the friction. So that is the principle of reverse shoulder arthroplasty. I have repeated it so many times that I hope it is clear now.